Hey, Obama. It's me, Jose. How are you? No, everything's good. I was just calling because lately I've been un poco nervioso. Yes, you're Americans. I want to build a wall. I want to get to your country so I can sell my tacos.
Yo, they're not going to support the wall. Don't need to worry about that.
Hold up, Obama. Who are you?
You don't need to worry about that either. Let me show you the map.
So, stranger, how are you so sure that these Americans will build this wall?
Well, you see, there's this thing called confidence intervals.
Mijito, ¿qué es eso?
Well, you see, a confidence interval, it's an interval estimate that displays the likelihood of proportion being within a set range.
Okay, so teach me. I want to know. I want to be sure.
I got you. You can sell your tacos whenever you want. Alright, so I'll be using data taken from a simple random sample of 152 American high school students. The amount of students that support the wall is 10. So we are going to display that using the variable p hat, 10 out of 152, which is about equal to 0.0066. And now q, which demonstrates the opposite, the amount of students that do not support the wall, is going to be 1 minus that of the p hat. So 1 minus 0.006, which is going to be 0.934. And we're also going to display the n, which is the amount of people within the sample, which is 152. Okay? So before we begin doing the math, we first need to ensure that this data is normally distributed. And to do that, we're going to be using a process called Rennie.
What's a Rennie?
My friend threw out high school in stats class. But Rennie is also going to be the guy that helps you get across the border. So R stands for random, N stands for normal, and I for independent. So to start off with the R, we need to ensure that it's a simple random sample, and it said so amidst the data, so we know that is correct. For N, we need to use something. NP is greater than 10. And so when we plug in the numbers, 10.032 is greater than 10, so that checks out as well. Now for independence, we're going to use N times 10 is less than that of the total population. And since this is data taken from a very large high school, we can assume that this is correct. So everything checks out. This is a normally distributed data set. So now that we've determined that this is normally distributed thanks to Rennie, we now have to find our first set of data points. The first one to find is going to be E, which represents the margin of error. Now to find that, we're going to be using Z sub alpha over 2 multiplied by the square root of P hat times Q hat over the N. Alright, so now that we have our formula set up, we need to input the data values. So to find E, we're going to need to find the Z sub alpha over 2. Now that is also going to be equal to the 95% confidence interval, which can be found on the Z-score distribution chart. And so that is going to be 1.960 multiplied by 0.066 multiplied by 0.934, and finally divided over 152. And when we do that, we're going to get a margin of error equal to 0.039. So now that we found the margin of error, we're going to need to find something called the proportion range. And that is demonstrated by the formula p hat plus or minus the margin of error. And when we plug in the math there, it's going to be 0.066 plus or minus 0.39. And because of this, we can say with 95% confidence that the proportion of students in support of the wall is between the values 0.027 and 0.105.
Stranger, with a proportion as low as that, I'll be able to go to the US.
Yep, you can do it with no problem. You're going to be able to make tacos, though based on this sandwich, you might want to improve your cooking a bit.
Hello?
Jesus.
Yeah, what's up, Uncle?
You're going to college soon, and you aren't even prepared. Not only are you failing your stats class, but you can't even identify the tarpon from this picture. I'll tell you what, though. If you show me the proportion of students that can identify a tarpon by its picture using a confidence interval of 99%, I'll pay for your entire college tuition.
Alright, don't worry, Uncle, I won't disappoint you. Oh god, I don't know what to do. I'm failing stats and I don't even know what a confidence interval is. And I don't even know what a tarpon is.
Looks like you're in quite the predicament, Sonny. I can help you out for a price.
Can I give you this hat and you can teach me?
Hand it over. A confidence interval is an interval estimate that displays the likelihood of a proportion being between a set range. I'll be using data taken from a simple random sample of 152 American high school students. The amount of students that can identify a tarpon by its picture is 18. So in this case, p hat equals 18 over 152, which comes out to 0.118. Q hat is the amount of students that cannot recognize a tarpon from its picture, which would be 1 minus 0.118, which comes out to 0.882. And then N equals 152, which is the amount of students that were surveyed in an urban high school setting. The critical value for a 99% confidence interval is equal to 2.576. So then we must test for RENI, which stands for random, normal, and independence. So for random, we know that it's a simple random sample, so we can check that that has been done. And then for normal, we have to test that n times p is greater than 10. And in this scenario, 17.936 is indeed greater than 10. So we can check that off. And then independence, we must say that n times 10 is less than the population. And in this case, we can assume that this is true. So then we must test for the margin of error, and the formula for this is z sub alpha over 2 times the square root of p hat q hat all over n. So then when we plug in the numbers, we get margin of error is equal to 2.576 multiplied by p hat, which is 0.118, and q hat, which is 0.882, all over n, which is 152. Then you know that your margin of error is equal to 0.067. So after finding the margin of error, we must find the proportion range, and the formula for that is p hat plus or minus the margin of error. So we know that p hat is 0.118, and that the margin of error right here is 0.067. So we can say with 99% confidence that the proportion of students that can identify a tarpon from its picture is between the numbers 0.051 and 0.185. And by the way, this is exactly what a tarpon looks like.
Oh, I see. Well, now, thank you, so much. Now, I can pass my stats class. I know how to calculate a 99% confidence interval, and I can identify a tarpon by just looking at its picture. Wow. And I can also go to college free. I'm indebted to you.
Well, thank you for the hat.